Okay, this is notes for Unit 10, Objective 4, and we're actually doing a couple of the problems from the assignment with you. Looking at problem number 1, I've already done the sketch, but just a reminder, g of x equals 2, so y equals 2, horizontal line elevation 2, and then we have the sine graph. The sine graph where the amplitude is 2, the period length is 2 pi over 2, which is pi, and it got shifted up 3, and got both of the curves labeled, f and g. We can see that there's 2 points of intersection just within the first period of the function. We are actually solving for all points of intersection between 0 and 2 pi. Okay, so points of intersection, f of x equals g of x, so 2 sine 2x plus 3 equals 2. Subtract 3, so 2 sine 2x equals -1, and divide by 2, and we get sine of 2x equals -1/2. Okay, now we have done something similar to this, but we haven't done anything quite like this before. So let me remind you of how it's similar. We have solved for sine theta equals -1/2. And that was sine is negative in quadrants 3 and 4. And since it's 1/2 and it's sine, it's a pi over 6 reference. And that would tell us that theta is equal to 7 pi over 6 and 11 pi over 6. Okay. Now in this case our theta is 2x. So 2x is equal to 7 pi over 6 and 11 pi over 6. But if we look at our graph, we can obviously see that if we extended the sine graph, there would be more points of intersection between pi and 2 pi, and that's still within our boundaries. So when we have the coefficient of the x, if it's a 2, we're going to say we're going to go 2 times around. If the coefficient of x is a 3, we're going to say we're going to go around 3 times. If it's a 4, we're going to say we're going to go around 4 times. Now, what do I mean by that? The 7 pi over 6, 11 pi over 6, this is our first time around. And so the second time around, how do we get a second time around? Well, we just add a rotation to each one of those 2 solutions. So 7 pi over 6 plus a rotation, so plus 2 pi, that would be 19 pi over 6. And then if we add a rotation to 11 pi over 6, that's 23 pi over 6. And so that's our second time around. So coefficient in front of the x was a 2, so we just go 2 times around here. Now ultimately we're trying to solve for x, not for 2x, and so to solve for x, wouldn't we just simply either divide by 2, but there's fractions over there, so it's probably a little bit easier to think of it as multiplying by 1/2. So we would get x, so if I multiply by 1/2, I get 7 pi over 12, 11 pi over 12, 19 pi over 12, and 23 pi over 12. And so there are 4 solutions in our boundaries of 0 to 2 pi, and if you notice, maybe you were concerned before that the 19 pi over 6 and the 23 pi over 6 were outside of the boundaries, but that was when we had it as 2x, and so now that we actually solved for x, notice that all 4 of those angles would be within the boundaries of 0 to 2 pi. So let's see, part B, we predicted 4 solutions, 4 points of intersection, and they are 7 pi over 12, 11 pi over 12, 19 pi over 12, and 23 pi over 12. Okay, we're also going to do problem number 3 together, and I already have the sketch for it. Again, g of x is equal to 2. It's not always equal to 2, but we're doing, the ones that we're doing the sketch of, we're trying to keep it fairly simple. So y equals 2, horizontal line, elevation 2. The tangent graph is a positive tangent shape. The period length is 2 pi, pi over 1/2, 2 pi, and it's shifted up 3. And so we can see the graph of just the first period. Now remember, tangent is also a periodic graph, and so there would be another shape out there to the right. When we set the two equations equal to each other, tangent x over 2 plus 3 equals 2. And so we get tangent x over 2 equals -1. Okay, now the coefficient for the x for the tangent is a 1/2. I know that when we were doing the up above, when we had the 2 for the coefficient, we went around twice, and if I said if it was going to be a 3, we'd go around 3 times, and so on. If the coefficient is a fraction like this, I would say let's just kind of do it almost as if it's just a theta. So just pretend it's a theta, and then we'll adjust for it. So we're just pretending this is tangent theta equals -1, and we think about it and we go, okay, well, where is tangent negative? Quadrant 2 and 4, and it's a pi over 4 reference. Okay, and so that would be the theta, which is x over 2, or 1/2 x over 2, equals, so quadrant 2, it's 3 pi over 4, and quadrant number 4, it's 7 pi over 4. And so now, solving for x, that's our ultimate goal. So to get x by itself, just multiply by 2. So x equals, so 2 times 3 pi over 4 would be 3 pi over 2. And the 7 pi over 4 would be 7 pi over 2. Okay. Now, given our boundaries, the fact that we're only solving for x between 0 and 2 pi, there's really only one solution here, just the 3 pi over 2. And so one solution, x equals 3 pi over 2. Now, you might be thinking, but wait a minute, there would be 2 solutions in our graph if we actually did the second period of tangent out there to the right. But the solution that we have over here to the that I already have highlighted in red, that's not within the boundaries. And so as far as solutions that are in the boundaries, that one wouldn't even count. Looks like it's negative pi over 2, and based on our solutions, that appears to be true. But the the 3 pi over 2 would be the next one that would be happening periodically, and that's what we have right there. Okay, continuing on with our notes, we're not going to be doing any graphing right now, we're just doing the analytical solving. So solving for all theta such that theta is greater than or equal to 0 or less than 2 pi. You've seen directions like this before. Obviously we did it with the graphing part too. It could also be written like this, 0 to 2 pi. Okay, so looking at number 3, we've already got 0 on that side. We've got more than one function. I'm noticing different angles even as well. It looks to me like we need to do a GCF. There's a GCF of cotangent to theta at the least. Cotangent to theta. There's also the 7 and the 14, so we also have that as well. So let's not forget about that. So GCF of 7 cotangent to theta, and that leaves behind root 3 cosecant 4 theta plus 2. Okay, something times something equals 0. We set each one equal to 0. 7 times cotangent 2 theta equals 0. Now, by the way, since we have these coefficients of the angles, make sure that it looks like a coefficient of an angle and not an exponent. Be careful about that sort of thing. We also have root 3 cosecant 4 theta plus 2 equals 0. So the first equation I can divide by 7, so cotangent 2 theta equals 0. And does cotangent ever equal 0? By the way, it is possible that when we set things equal to 0 that they might be an impossible situation, and so you note that. But cotangent can equal 0. Remember, cotangent is x over y. And so at pi over 2 and 3 pi over 2. Now we're just pretending it's just a plain old theta angle at the moment as we're thinking about those situations. But that's what the angle 2 theta is equal to. 2 theta is equal to pi over 2 and 3 pi over 2. Now, remember what we were doing before, the coefficient, if the coefficient is bigger than 1, then we're going to think of like going around twice if it's a 2, or if it's 3 times, if it's 3, you think about going around 3 times, or 4, you go around 4 times, stuff like that. So this is the first time around, and you get the second time around by simply adding a rotation to each one of the solutions from the first time around. So add a rotation, add 2 pi, so that's 5 pi over 2. Add a rotation to this one, 7 pi over 2. And that's the second time around. And now if we finish it off, because we're actually solving for theta, not for 2 theta, so if we multiply both sides of the equation by 1/2, we will get theta. So theta equals, so we get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And if we think about the boundaries of what we're solving for, between 0 and 2 pi, all of those fall into those boundaries. Now, we're not done. We still have the other part of the equation. Okay, so if we set that one equal to 0, I can subtract 2 and divide by root 3. I get cosecant 4 theta equals negative 2 divided by root 3. Okay, now, for many of you, probably cosecant, not a problem. But maybe you say, I think a little bit better, and it's reciprocal. And so we could trade in the cosecant of 4 theta for sine of 4 theta, and then do the reciprocal. So 2. You don't have to do that. It just might make it a little bit easier. And you look and you go, okay, sine, it's negative, quadrant 3 and 4. And it's a pi over 3 reference. And we've got 4 theta, the angle, first time around, quadrant 3, quadrant 4, 4 pi over 3, 5 pi over 3. Now, that's the first time around. And so, add a rotation. So, adding 2 pi, adding 6 pi over 3. So, 10 pi over 3 and 11 pi over 3. That's the second time around. How many times around do we have to go? We have to go around 4 times. Add another rotation, 16 pi over 3 and 17 pi over 3. That's the third time going around. And the last time going around, add another rotation, so 22 pi over 3 and 23 pi over 3, and that's the 4th time around. Okay, now, we do need to multiply both sides of the equation by the reciprocal so that we get just theta. And so theta, okay, so the 1/4, some of these are going to reduce, and so fractions should always be reduced. So 1/4 times 4 pi over 3 is pi over 3. The 5 pi over 3 times 1/4, that one does not reduce, so 5 pi over 12. The next one reduces just a little bit. We get 5 pi over 6. The next one we get 11 pi over 12. The next one does reduce. We get 4 pi over 3. 17 pi over 12. Next one reduces a little bit, 11 pi over 6, and the last one does not reduce, 23 pi over 12. And if you take a look at all those, again, they fall within the boundaries of 0 to 2 pi, even that 23 pi over 12. So now there's an infinite number of solutions if we do not put boundaries on ourselves, but we have the boundaries 0 to 2 pi, and so this is all the theta between 0 and 2 pi that satisfy this equation. Okay, moving on, same directions. We've got secant squared of 2/3 theta plus secant of 2/3 theta minus 2 equals 0. Looking ahead, the coefficient is 2/3. If it's a fraction between 0 and 1, or between 0 and 1, then I would just kind of do it as if it's just a plain old theta and work it out, and then we'll probably have to look at our answers and just make sure that the final result, the answers are between 0 and 2 pi. But factoring, trinomial, GCF is 1. But we would need a secant 2/3 theta and another secant 2/3 theta so that we get the secant squared 2/3 theta, and we also get the secant 2 theta out in the middle. Multiplies to get 2, technically negative 2. Has to be a 2 and a 1. And I want a positive 1 out in the middle, so it looks like we want positive 2 and negative 1. Notice that also gets us the negative 2. Okay, so something times something equals 0. Set each one equal to 0. Secant of 2/3 theta minus 1 equals 0. So equals 1. I added 1 to the other side. Secant 2/3 theta, and I would subtract 2, so minus 2. Probably a little bit helpful to look at it as a fraction, so negative 2 over 1. 1 over 1 is the same thing. Now, much like on the last problem where we were thinking of the reciprocal, maybe you don't think so well in secant, we could trade it in for cosine. So cosine of 2/3 theta, and then the reciprocal, of course the reciprocal of 1 is 1. And cosine of 2/3 theta, but the reciprocal of -2/1 is -1/2. So that one's probably a little bit easier for us to think of. Okay. Does cosine of an angle ever equal 1? Sure. Out here at theta equals 0. Over here at pi, it's -1, so we don't want that one. Cosine of an angle equals -1/2. Well, yeah, quadrants 2 and 3, and it's a pi over 3 reference, and so that would be giving us 2 pi over 3 and 4 pi over 3. Okay, now that's just some plain old angle. Let's go ahead and grab all those, because the specific angle we're solving for at the moment is 2/3 theta. And so we had 0, 2 pi over 3, and 4 pi over 3. Now we're trying to solve for theta specifically, so let's multiply by the reciprocal, and we will get theta equals, okay, 3/2 times 0 is still 0. 3/2 times 2 pi over 3 is pi, and 3/2 times 4 pi over 3 is 2 pi. Okay, now remember, we only want the thetas such that we're between 0 and 2 pi, but the 2 pi is being excluded. Therefore, we really only want the 0 and the pi.